Hello, viewers, and welcome to this new year, 2024. In this video, we will be looking at quadratic equations. And in the quadratic equations, we will be looking at how to solve two things. One, the sum of the roots, and two, the product of the roots. So let's start by asking a very candid question. How do we find the sum of the roots of a quadratic equation? And also, how do we find the product of the roots of a quadratic equation? Now, let's look at the first method. So what we will do is to solve for the roots of the quadratic equation. When we talk about roots, what do we mean? The roots of a quadratic equation are simply the solutions of that quadratic equation. So in this first method, we will first solve for the roots, that is, get the solutions, and then we carry out the operation of addition, that is, finding the sum, and then also the operation of multiplication, that is, finding the product of the roots. In the next method, what we will simply do is to apply the appropriate formulae that has already been established and which we will be carrying out in this video. But in reality, the better method of these two methods will be method 2. But your choice will be as good as mine. Now, let's quickly look at the general form of a quadratic equation, which we can clearly see represented as ax squared plus bx plus c is equals to 0, provided a is not equals to 0. A quadratic equation is as shown in the general form as ax squared plus bx plus c is equals to 0, provided a is not 0. So what happens when a is 0? That tells you that the first term, ax squared, becomes 0, and then you're now left with bx plus c, and that becomes a linear term. So the condition for which our formula or algebraic expression must be a quadratic equation is when a is not equals to 0. Now, what we'll be looking at now is an example of a typical quadratic equation where we will be solving for x in method 1. So if we look at the general form of the quadratic equation above, we see that a is the coefficient of x squared, that is, a is multiplying x squared, b is multiplying x, b is the coefficient of x, and then we have c being the constant term. And by analogy, if we look at the example, x squared minus 5x plus 6 is equals to 0, our a term, that is the coefficient of x squared, what is multiplying x squared in this particular case is 1. And then b, which is the coefficient of x, what is multiplying x in this particular case is minus 5. And then c is the constant term. And in this particular case, an example, our c is equals to 6. Now, we will be applying the quadratic equation formula to quickly solve for x. And since we have the values of a, b, and c, we will be substituting accordingly and simplifying as it can be clearly seen And in solving for x, we have x is equals to 5 plus or minus 1 divided by 2. That tells you that x is either 5 plus 1 over 2 or x is equals to 5 minus 1 over 2. So that gives us 6 over 2 for the value on the left-hand side, which is x is equals to 3, and the value on the right-hand side, which is x is equals to 4 over 2, which is simplified as x is equals to 2, gives us the solutions to this quadratic equation. So we have one solution, which is x is equals to 3, and the second solution, which is equals to x, is equals to 2. So in this method 1, we successfully solved for x is equals to 3 and x is equals to 2 as the solutions to the quadratic equation. Remember, the whole objective is to find the sum of the roots and also the product of the roots. And like we earlier said, the roots are simply the solutions. Now that we have the solutions, we can calculate the sum of the roots, which is simply 3 plus 2, which gives us 5. And then we can also find the product of the roots. Product is simply the multiplication of the roots, which is 3 times 2, and that gives us 6. So we went through the whole process of method 1. Method 1 being solving the quadratic equation in order to get the roots before applying the sum of the roots and then applying the product of the roots. Now we'll go to method 2. Method 2 simply goes straight to the point. The sum of roots of a quadratic equation where you have alpha as a root and beta as a root is simply equals to minus b over a. The sum of roots has been established as minus b over a. And we know what our b is, and so we will just simply substitute, and we know what our a is. So alpha plus beta, alpha being one of the roots, beta being the second root. So the sum of roots, as we have substituted clearly, gives us 5. Now, product of roots. The product of the roots, product being the multiplication, that's alpha, beta, that means alpha times beta, is simply equals to c over a. We know what our c is, 6, and we know what our a is, which is 1. So alpha, beta, which is the product of the roots, is equals to 6 over 1, which is equals to 6. So in less than 2 minutes, we're able to calculate both the sum of the roots and the product of the roots for the specified quadratic equation. So, like I said earlier, your guess is as good as mine. The preferred option will be method 2. Now, let's look at these examples of quadratic equations where we're able to calculate the sum of roots and also the product of roots without going through the process of solving for the roots of the equation before being able to calculate the sum of roots and the product of roots. All we will simply use is the formula established as above, where our sum of roots is simply minus b over a, and the product of roots is simply c over a. So our first step will be to identify what our A, B, and C values are in each of the quadratic expressions. Now, in this first quadratic expression, we have x squared plus 2x minus 15. Our A is 1, our B is 2, and our C is minus 15. So A being 1 because A is the coefficient of x squared. Whatever is multiplying x squared here is 1. B being the coefficient of x, what is multiplying x here, we have it as 2. And then C being the constant, we have it as minus 15. So what we'll simply do to find the sum is minus B over A, which is minus 2 over 1. And then that gives us minus 2. And then to calculate the product, we'll be establishing or we'll be incorporating C divided by A. C is minus 15 divided by 1, and that gives us minus 15. So for this particular quadratic equation, we've been able to find the sum of the roots and also the product of the roots without calculating the value of the roots. So let's look at the next example, and let's look at the solutions. So we are actually establishing the sum of roots and the product of roots of the quadratic equations without calculating the roots. All we are simply doing for these 5 examples is just to identify what is our A, B, and C based on the general terms, and then applying the relevant formulae and the formulae. So we can see clearly that for the 5 quadratic equations, all we did in order to calculate the sum of roots and also the product of roots was simply to apply these formulae. That is, for the sum of roots, minus B over A, and then for the product of roots, C over A. And we were able to get the answers. All we did for each of them is to identify what our A is, what our B is, and what our C is, and then simply incorporate them into the applied formula. And that is what we did for each of the 5 examples. Kindly subscribe to this YouTube channel so that you can get additional and more videos that will add value, and you'll be the first to see it when it comes. Also, kindly like and share. Thank you.